So I want to explain everything we've done so far um, has been with virtual machines, right? There are three types of servers. Sorry, two types of servers. There's a physical server, right? The one that this physical server sits in the office. You can see it, you can touch it, right? You can feel it, right? All that stuff, right? And and you can pretty much see that the physical server is very, very costly, right? Like, for example, a Dell PowerEdge. This is the name of the server, for example, the Dell PowerEdge 2950. It's a Blade server, right? This is a physical server that sits in the office, right? Another type is a tower server. You have a HP tower, HPT 610 server, right? It's a tower server. So let me show you guys what I'm talking about. HP Tower 610 server. That's it. It's a tower. When it says a tower, it looks like this. It's a tower. It's taller like this. Then when they say it's a Dell PowerEdge 2950 Blade server, it's flat. It looks like this. It's flat. That's a Blade server. Okay? That's a Blade server. Okay. And then what is a rack? A rack server, right? It's where you store servers. This is a rack, server rack. They store Blade servers in there like I inserted in there. Okay. So these physical servers live in these rooms. These rooms are called data centers. I'm going back to the beginning of what we're talking about because when you in the interview, they'll ask you, hey, Isabel, you are a cloud engineer or SRE, but what were you doing 6 years ago? What were you working with 6 years ago? So you have to be able to know all this old technology because 6 years ago, this is what you were working with, right? You're working with Blade servers and what kind of servers are you working on? You call these names. You'd call these names, the Blade servers, all these things, right? Um, so fast forward, as technology grew, these physical servers now were too expensive. So they decided to take this type of physical server like this, right? Then they installed a software technology, right? Underneath this software, they install it on this server, right? Called a hypervisor. The technology is called a hypervisor. Hypervisor. The company that makes hypervisor, a Chinese company called the Zen Hypervisor. I think that's an American company, but the Zen Hypervisor is a technology that when you install it on your machine, even if you install it on your laptop today, your laptop will be able to host many, many small machines. So when you install an hypervisor on here, and let's say the host operating system for this server, when I mean the host operating system, I mean that the original operating system that the server came with, let's say it's Linux. Let's say it's Red Hat Linux, or let's say it's Ubuntu. This is the host operating system, right? The host OS is Linux. But because we have installed the Zen Hypervisor on here, which is a software that creates virtualization, right? We are able to now come and install Windows here, which is a guest operating system, guest OS. We're able to install Amazon Linux here, which is a guest OS. We're able to install other things. Sorry. We can install other things, small things on this server. And we can install, we can install what else? A Red Hat Linux. Yeah, like that. Like that. Right. So this Zen hypervisor, the Zen hypervisor here, I'm gonna put Zen here, so you know that is Zen hypervisor. Zen is a hypervisor. It has made this machine, this huge machine that is so expensive, right? This Dell. Look at the prices of these machines, $32,000, right? A company cannot afford this, but Amazon or AWS, Amazon Web Services bought these machines, right? They installed the hypervisor on them, right? They have a host operating system like Linux, Ubuntu, and then they created small spaces called AMIs on them. So when we go to EC2 and we launch a virtual machine, we're literally launching a virtual machine on this big box right here. So Amazon owns this host, this huge host. And so, but they have these available slots on here. This machine has how many memory? Let's see what it is. It has 32 GB, right? 32 GB of RAM. And what else? See, 32 GB of RAM. So this machine is huge, very huge machine, right? 32 GB. So pretty much Amazon will buy this huge machine and then install the hypervisor and then use it to sell small EC2 instances on that. That'll be taking 1 GB. So T2 micro is 1 GB, one CPU. So on this machine, you can have 32 virtual machines, EC2 instances. That's the power. So this is virtual machine, virtual servers. That's the power of virtual servers, right? That's the power of virtualization. You can take one huge machine, and from there, you can have many small machines. These small machines on that host, they're all guests. They're not permanently there, they're guests, because when you terminate your instance, boom, it's gone. Another person could become and create a new instance. It comes back and takes that same space that is there. Boom. And this is Amazon Linux. Boom, like that. And you still have more space here. So you have 1, 2, 3. If you have three T2 micros, they have to consume only 3 GB of memory. So they still have how many left? 29. So this server can have 29 more servers on there. So that's the difference in virtual servers and physical servers. Virtual servers is a physical server that has been virtualized, doesn't have hypervisor, and you can have many guest operating systems on there. But a physical server is only one huge machine, and you cannot virtualize it. So then that question, this question will come in an interview. If the interview is trying to see what you have been doing before you got here, before you got to SRE, they will ask you this question. Any questions? Any questions? Okay, cool. So because of that virtualization, what problems we have traditional IT infrastructure? So the traditional approach, which is what I just discussed right here, right? Traditional approach of you buy a server, you wait for it, it comes to your house, you configure it, all those things, right? It takes a long time, right? Um, it takes a long time, right, to get to your house, all that stuff, right? And so the new or the better way is to have, or the traditional approach has, you have to install and configure it. It's time consuming, right? You have to buy the server. Like this server, when you order this server now from Dell, you would take a while to come. They still get it by Wednesday, December 11th, right? So today is what, the 2nd. So why do we have to wait December 11 to get a server? We can just go to AWS and just buy a server and use it today, and it's ready to go. Right, but because this is a physical server, it has to be shipped by FedEx to come to our house. So that's one of the issues of traditional IT approach. Traditional approach is time consuming. You need to perform installation and configuration on every server and every environment, dev, quality assurance, staging, and production. So if we order 10 servers from Dell, that's 10 machines that's going to come to our house. We're going to plug it, connect to the internet. It's time consuming, right? Compatibility and dependency. You need to keep resolving issues related to the libraries and dependencies. Inconsistency across environment. Very hard to track changes across dev, QA, staging, and prod environments. And they end up inconsistencies. You can see here, we have the web server, Nginx, we have the app server, and then you have databases, right? The 3-tier. You can still have the 3-tier on one machine, on one huge machine like this. You can have the 3-tier on one huge machine, but it's not recommended because what does that create? When you have all your web server, application server, and database on one machine, it creates what? Single points of failure. If you write this down, guys. Single point of failure. SPOF, single point of failure. I want you to add this to your tell me about yourself so that I have experience in designing applications that can avoid single points of failure. Meaning that you know how to decouple systems, right? Instead of having the database, application, and web server in here in one server, you decouple it. You have web server on its own virtual machine. You have application server on its own virtual machine. And you have database server on its own virtual machine. Like that. Like this three, 1, 2, 3. Right? This is called decoupling. Instead of having it in one server, you have it in 3. So the problems of this is you have the web server, app server, and running in the same system. They're using the same libraries, dependencies. They have a host operating system. And then this is the hardware infrastructure. This is where you have the memory, CPU, storage. This is the host operating system. This is the Windows server. On top of the Windows server, you now install Nginx libraries, Java libraries, dependencies for databases. You install them, right? Now, operational support. You need more resources to handle operational issues on a day-to-day basis. You need server support, hardware support, software support, patching releases. Patching is upgrade. Okay, write this down. Patching means upgrade. You need to upgrade the system from version 1 to version 2. That means that's what patching is. Whenever Microsoft releases patches or upgrades, you need to patch your server. Patch your server means you need to upgrade them. So developer environment. When a new developer joins the team, it takes time to provision his development environment for him. What does that mean? What I just gave you guys this task that I gave you guys like this, all of this task, this is configuring a developer's environment. This is developer's environment. This VS Code, all these extensions for Kubernetes, Docker, everything set up. This is a developer's environment. So it takes time to set up a developer's environment because you have to go through these steps. But go through these steps on the physical server, not on your laptop, on the physical server, So it takes time to do that, right? So what happens? With physical machines, like I just explained it over the back. I wanted to do that first, then bring it here. With physical machines, this is what you have. You have the hardware, you have the host operating system. The host operating system is the operating system that comes with the machine. What I have now here is a MacBook. I have a MacBook, but if I install the Zen hypervisor on my laptop, I'll be able to run Windows. Let me see if I have an Oracle VirtualBox. VirtualBox. Yeah, or remove VirtualBox. Okay, I don't have it anymore. I used to have a VirtualBox. So on this machine, I can run Windows because I installed this hypervisor on this machine. I can run Windows, I can run Linux, I can run many different systems. So the physical machine, you have the libraries and dependencies. Libraries are simply packages that you need. Like when you do the yum install, with the yum install, you're installing libraries. You're installing dependencies. The yum install, HCPD, that's all libraries that you're installing. That's all what libraries and dependencies are. It's what is needed to run an application. If you want to run a database, you need a JDBC dependency. So you need to install Java. The database is a Java database. You need to install and configure Java. That's all it is. It means that the database depends on Java to run. For example, for you to be able to attend this class, you needed Wi-Fi. So Wi-Fi is a dependency for you to join the Zoom class. So that's what dependency means. So they'll ask you, for example, what dependency did you use to run the database? Or a Java. If it's a Java database, you need to install Java on that system. That's all it is. For web server, for example, this web server right here, you need to install Nginx, right? So for example, you can come here and you can do a sudo app get Nginx -y sudo app install. Let's see, install. No, sudo app get what is it? Sudo app get install Nginx. Right there. You see, guys, I don't cram make commands there. I don't cram commands. I'm teaching you guys sudo app install. I don't cram commands. I don't advise you to cram commands. Boom. Life is very easy. You want to continue study it. Boom, that's it. I'm installing Nginx on our Ubuntu server. So this is what you see here, the libraries and all these things you need to update the server. So escape. So you see, these are all the libraries. You see, lib Nginx library. Lib means library, Nginx, right? So for you to be able to run a web server, this web server, for example, dormall.net, you need that for to run this. So, right, but I already had it installed. I just upgraded it, right? So that's what I mean by libraries. For things to run, you need to install libraries, you need to install dependencies and everything. And when it ran, it restarted the services automatically because it was already there, right? So what I'm saying is everything that you run, web server, application servers, they have their libraries, they have the dependencies, right? So that's what this is a physical machine. Now for a virtual machine, on top of the hardware, we install a hypervisor. Okay. On top of the hardware, we install a hypervisor. And the hypervisor now enables us to virtualize the system. Now, you see, you have virtual machine number one. Virtual machine number one has an operating system. We call it the guest operating system. It could be Windows. And then on that operating system now, he has his libraries, his own dependencies, and he runs his web server, application server, database. Virtual machine number two, you have an operating system, a guest OS. He has his own libraries, he has his own dependencies. He has a web server, database server. So on this one machine, we could only run one application. When I say an application consists of 1, 2, 3, right? An application consists of all three of these things, right? So a three-tier application, right? An application consists of a web server, application servers, and database. Yes or no? Right? An application, right? Hold on. I'm trying to confirm, make sure you guys are on the same page. Geico.com has what? This application has how many layers?
3 layers.
3 layers, right?
Yes.
Kobe, are you here? Kobe, are you here? I don't think Kobe is here.
Yes, it has three layers: the web
Yeah.
application and the database.
Yes. Whenever you create an account and you store your information and you log in, your information is stored in the database, right? When you buy auto, you buy home, you buy renters insurance, it's stored in the database. Whenever you come and you want to buy both insurance, it will just retrieve your same name and address and everything and credit card information from the database, and then that we don't have to enter it again. So these applications are made up of three things. So when they say, what application are you running? Don't just gonna say I'm running a Java application, right? You have to mention that we're running three-tier application that has web layers, app server, and database. So as you can see, virtual machines what we've been working on this whole time. This is an EC2 instance. And you can see that we're really running on one host, one big physical machine. But because of virtualizing, we don't even know. We see our own EC2 instance, right? And we run our own thing like that. So the advantage of virtual machine over physical machines is that with virtual machines, you can do more with that server. You can make more use of that server, right? You can have a guest operating system here, right? But the physical machine is just, you can just run one application. But here you can run two applications or more. If you want to create more virtual machines, all you have to do is the hypervisor is the one that manages it manages the resources, right? The resources on these servers. The Zen hypervisor manages that, right? Like the memory, the CPU. He cannot allocate more memory to this system than this system. So whenever you install Hypervisor, they'll configure it that each virtual machine will have a fixed number of memory. That way so that you can, and then they have a fixed number of machines on that server. So if it's gonna be 10, and then everyone will have 3 GB, that's how it's gonna be. So when you create a virtual machine and you want 5 GB of memory, it will fail, right? That's why sometimes when you want to create EC2 instances, it may fail, right? So that's that. Any questions here before I go to the next step? Is it clear? Okay. What does Docker come in? Because we know that we run applications as a package. What does that mean as a package? Geico.com has web server, app server, databases. Whether it's in physical machine or it's a virtual machine, we know that it's web server, app server, databases. And for these things to run, they have dependencies on they need libraries and then the dependencies. Okay, cool. So what if we had a software that software, when we install that software on our system, it comes with everything at once. Okay. That way we don't have to install anything. It just comes prepared. Like, for example, when you buy your Fire Stick, Amazon Fire Stick, it comes with all the apps. It comes to Netflix, YouTube, everything. It just comes with all the apps. That's Docker. That is Docker. So Docker with a physical machine, you see that Docker container for web server. So you're going to look for an Nginx container. Nginx container comes with all the libraries and dependencies to run Nginx web server. Boom, done. So I don't have to run sudo apt install Nginx. We just go to Docker desktop. Where is it? Oh, it's not here. We'll just go to Docker Hub. Docker Hub, right here. The hub, not the desktop hub. We just go to Docker Hub right here. And you go to explore. I verified my email address a long time ago. I don't know why it's doing this nonsense. Come on now. Oh, I want to just show you how I can go pull a Docker image Okay. You just come and look for Nginx. Boom. This is the Nginx Docker image. Come on now. And you just download it and use it. Done. For your application. That's it. This is the official image for Nginx web server. So if I wanted to build a web server for using Nginx web server, I'll just come here and copy this command and go run it on my local system or on the server that I want to run. Docker pull is going to pull that image. What's wrong with my keychain? Asking for my password. Anyway, oh, it's still pulling the image, even though I'd say deny. So it's pulling the Nginx image now. Everything that is needed to run an Nginx web server is downloaded, is in that image. So I don't need to go into the server and install each individual library for run Nginx. This is very, very beneficial because every time we want to run Nginx, we just run the container. It's called a Docker container. They call it container because when you're shipping, if you know containers that you use to ship goods or cars, right? Right, everything is in the container, right? When you want to ship a container from here to Africa or from here to anywhere, you load the container. There's everything in there, right? When you load the car, you're loading the tires, the engine, everything is in the container. So everything needed to run in the Nginx server comes with this container. So when you install Docker on a physical, so you have the hardware, you have the host operating system, so Linux or Windows, and you install Docker on that physical server. Now, when you want to run an application, a Geico application, and let's say it's Java application, you need a database, you need an application server, you need Nginx. What do? You just download an Nginx container, you download a Java container, you download the MySQL database container, 2 or 3 containers, and you run them and connect them to each other. Boom, you're done. You run your application. So all this sudo yum install, sudo yum that it doesn't exist anymore. That goes away. Okay, that goes away. After you download and so I'm doing it on my local machine, but normally this command will run on the server. This I wanted to run this on the server itself. On this physical machine, I'll run it here. After we have installed Docker, I'll run it here. Docker pull, and then when I run that Docker pull image, it pulls the image local, then I just run a Docker run Nginx, and it will run the image, and then you will bring up the web server, and then that's it. We're able to use it. That's pretty much it. Very, very easy. I also emailed you guys a Docker cheat sheet, I believe. That's it. You see, it's starting the application, starting the worker processes and everything for the application, for the Nginx application, right? Docker is very, very easy. Same thing for the application server, right? We'll just download that container. This is a Spring Boot. This leaf thing here is a Spring Boot image. So you go to Docker Hub and you look for Spring Boot. It's a Java development framework, Spring Boot. So there are many, many of them. You just hit enter, and there you go. If it's Maven, CentOS, this one is compatible with the CentOS operating system, Maven. And that's it. You just want to Docker pull this image down. I can kill it. I don't really care about it, right? I can kill it, right? And you just want to Docker pull, and you pull the image. I can still say deny here. And you pull the image down, and then you run it, and that's it. If you want a MySQL database, you come to Docker Hub and you look for MySQL database. And that's it. And you just run this command, Docker pull MySQL. I'll kill it. I don't really care, right? Docker pull MySQL, it will pull the image down. And then when you do Docker run, it runs it. There are 4 main commands: Docker pull, Docker run, Docker build, Docker push. I'll explain all of them, right? Docker pull is to pull the image. I call it image because it's an application that has been packaged. As a package. It's an image. It's like an EC2 AMR image, right? When you run it, it creates the container, creates a full system, but it's all in a container. It comes as a package on its own. It runs in isolation, only within itself. It runs only in that little box, that container. Everything is in there. It has its own memory, your own CPU, everything is in that box, right? The interview question now has come around is like, and they ask you in an interview, how do you plan to isolate your application? How do you plan to isolate your application in terms of like isolation? How do you plan to do that? You run a Docker container. That's your answer. You run a Docker container. Okay?
Okay. Debo, I have a question, please. Hello?
Yeah, go ahead.
Okay. I want to know this server, is it that maybe if we are using AWS, the EC2 instance, is it that we have to create a server first, maybe for the application server, another server for,
No.
or you do this in the same command?
No. I'm happy you asked that question. No. Guys, before we have been doing this, we have been creating one server for web server, another server for app server, another server for database. This is 1, 2, 3 EC2 instances, right? That's what I've been doing, right? But I'm saying that this approach is good, but this approach can be difficult to manage because we need to come in this web server, EC2 instance, and install things to run Apache web server or web server. We need to come here and install things to run an application server, which is the Java things, the dependencies. For database, we need to come here and install things. Now, we don't need to install things anymore. You can take one big machine, one big EC2 instance, Isabel, one big EC2 instance. It could be an M5 2x large, which has 16 virtual CPUs and 32 gigabytes of RAM. On this machine, we can install Docker on this machine. This is what I'll do, they'll install Docker on this machine. Docker. And once you install Docker on this machine, now you can now go and start pulling the various images for Nginx web server. You can pull the image for a Java application. Sorry, the Java the Nginx web server container, right? Container. The Java application container and the database container. You get where I'm coming from now? And the database container, MySQL container. That's what I'm talking about here. You're running 3 containers within one huge host. Nginx, Java, MySQL. Was that your question, Isabel?
Yes.
Right. So with this approach, this is the approach here. Now, this is running with physical machines. Now, with physical machines, we're still limited because with the physical machine, we can only run 3 containers, one for web, one for container, one for databases. And so that's our application. That's Geico.com. That's it right there. When you go down to virtual machines, oh, we can do more. We can have 2 virtual machines on a physical host. And with that, we can run 2 applications that has, each of them have their own web server, app server, and database server. So this is what we are going to do in class. This is what we are going to do in class. This is a virtual machines with Docker. Physical machines with Docker is not recommended. Physical machines, not recommended. Virtual machines, recommended. If you want to containerize, the word is containerize. If you want to containerize your application, then you go with Docker containers. Then you install Docker, not on the original host, but you install Docker now on your EC2 instance. So you're going to create an EC2 instance. We're going to install Docker on that EC2 instance. And from that EC2 instance, we're going to pull images for Nginx, for Spring Boot, for MySQL. And when we do a Docker run, we're going to run all of them and we'll have our application up and running. The advantage is that we are not, let me repeat again, we are not installing anything on these servers. We are not installing anything on these servers because all you have to do is do a Docker pull image for Nginx. You're not going to install any libraries or dependencies for Nginx because when you do the Docker pull image, the image for Nginx that is on the internet, right? It already comes with all the dependencies. Look at this. Look at what they tell you. For example, MySQL image, they tell you starting the image, when you run it, give it a name. Since it's a database, they tell you how to run it here. They tell you what it comes with, tell you how to use the image. Everything is there. Environment variables, everything. If it's for Nginx, web server, they tell you everything, how to use it. Like that. Right? Like that. From Nginx, everything, they tell you how to use it. Everything is there. All the port numbers, configure how to run it, everything. The reason for this is to avoid the issues that we discussed in the beginning. These issues. We don't have time. We don't have time to be installing and configuring servers, to be running sudo yum install. We don't have time to be configuring and installing things on every server. We don't want to have incompatibility issues. So we'll just go to Docker Hub and we'll just do a Docker pull and it will give us the latest version of it, which is 1.27.3. And we're good. And we'll run the same image on all our environments, dev, stage, test, production, so that we don't have this issue of incompatibility across environments. That's the advantage of running Docker containers. Most companies use Docker containers. I had to teach you virtual machines, however, though, right? Some companies still use virtual machines, but most companies, most advanced companies now use Docker. The interview question will come like this. How do you save time in deploying an application? Use Docker containers, because you can just go on the internet, do Docker pull, Docker run, boom, and it's running. How do you avoid incompatibility across different environments? Docker containers is your answer. How do you isolate applications? Docker containers is your answer. I know people like, damn, people. So there was more. Yes, I said the best for last. These last classes, the things you're going to learn are the things you're going to be doing on the job. These last 2 weeks, the things you're going to learn are the things you're going to be doing on the job on a day-to-day basis. So please give me all your attention. I'm begging you. We're done. December 11th class is over. And you start interviewing. You start applying for jobs or interviewing on LinkedIn. Okay? So these are advantages of Docker. Like I just said to you, I think I'm a little bit fast. Advantages of Docker is flexible. Even the most complex applications can be containerized. The most complex applications can be containerized. It's very lightweight. Container leverages and share the host kernel. They share the same host, making them much efficient in terms of system resources than virtual machines. Virtual machines take all the memory and CPU of the hosts. Virtual machines, right? Look at them here. They take the memory of this infrastructure, right? Whereas containers take the memory of the virtual machine. So the virtual machine only has 2 gigs of memory. It will take about 1.2. It will not take everything. Because it's efficient, because The containers only use what they need. Let me explain in great detail. An Nginx container may only need, it needs what? It needs 1.2 GB of memory to run. Whereas if you install Nginx on a virtual server on its own EC2 instance, this EC2 instance may have 8 GB, right? It has 8 GB of memory. So the EC2 instance is using the whole 8 GB of memory because it's available to it. But in the container here, even though this machine has 32 gigs of memory, right? It has 32 gigs of memory. This container only needs 1.2 gigabytes to run. So it's very efficient. Containers only use what they need to run. That's all. Because they're running in a box. It's like if you're in a hotel, you're only going to use your hotel room, right? But if you're in a house, you're using the light in the kitchen, living room, front door, everything, because you are in a big space. But if you're in a hotel room, you're only using your hotel room light. That's the difference between a virtual machine and Docker container. Virtual machine, the 8 gigabytes is available to the whole virtual machine. So it's pretty much waste. It's waste. There's a lot of waste in virtual machines. With containers, it's only using 1.2. That's all it needs to run. So there's no wastage. Okay? And then it's portable. You can build a container, deploy it to the cloud. You can run the containers anywhere. Virtual machines, physical servers, you can run it anywhere. Azure, you can run it in AWS, you can run it in Google Cloud, you can run it in VMware, you can run it in Alibaba Cloud, you can run containers everywhere. So let's say you have an application running in Google Cloud. You want to move to AWS. What do? Take the image, copy it to AWS, do a Docker pull image in AWS, run it, it's running, done. Very, very easy. It's loosely coupled. Containers are highly self-sufficient because, again, it's a container. It comes with its own memory, storage, CPU, everything is there, right? They're very self-sufficient and encapsulated, allowing you to replace or upgrade one without disrupting the other. So let's say you have an application like this. Let's say you have the Geico.com running on 2 servers. And then now you want to upgrade this Geico.com, this one right here, to version 2.1. So they're all running 1.1 right now. You want to get it both on a 2.1. What do? You come here first. You do something called a rolling upgrade. You upgrade this to 2.1, and you start serving to some small amount of customers first to test it, right? To test it, send small amount of customers to test it first, and then after that, you now roll over here. You move 2.1. You serve 20% of customers to try 2.1. When it's now good, they like it. You now come here. You now move all the requests that was coming here. You repoint those requests to come here now to the new 2.1. You go ahead now, you upgrade this to 2.1. Then now you go back and now connect it back to load balancer. Load balancer now balance it now across then. So now they now have 2.1, 2.1. It's called a rolling upgrade. With Docker, it's very, very, very easy to do rolling upgrades. Okay. It's scalable. You can increase and automatically distribute container replicas across the data center. So you can add more containers. Like on this machine right here that you see here, we only have 2 virtual machines, right? You can come into this machine and add more containers. You can add a Redis container in here. You can add another container for a jump box. You can add many containers in here. So that's how you scale, by adding more containers. All you have to do is do a Docker pull, Docker pull, Docker pull, Docker run, Docker pull, Docker run, right? Docker pull, Docker run, right? That's all you have to do. And then again, it's secure, right? Containers apply aggressive constraints and isolation to process without any configuration required on the part of the user. So when you see Geico is able to create your account, it's because it's only your account. All your information is only within your account. It's very highly secure because it's within a container. No one can see it. No one can touch it. No one can get inside of it. Any questions on Docker? Any questions? Any questions at all? before I go into the architecture. Any questions, guys? So Docker terminology. With Docker, these are the various terminology in Docker. You have the Docker daemon, Docker-D. I see you guys know everything that runs on Linux has a daemon, has a background process. This is what it is. A background process is the daemon, right? And then the Docker daemon listens for Docker API requests and then manages Docker objects such as images, containers, and networking things, right? The Docker daemon, like I said, in Linux, everything has a background process. When we did install Apache, it has a background process. It's called Docker daemon. Then you have the Docker client. I'm not going to go into too much detail because you don't need to know the too much detail. I'm just going to keep it very high level. You have a Docker client. The Docker client is like, client-server relationship, right? The Docker client is what we use, what we operate with, right? The front end. When I run Docker this command right here, this is my client. Docker pull MySQL. This is me in VS Code. My client is VS Code. I'm sending a request to the Docker server, which is in the hub right here. This is Docker hub. This is the Docker server to give me that image called Nginx. So I sent a request from my Docker client, which is installed here. Docker -- version. I'm running Docker version 24.02, right? So I run a client called Docker pull, which is sending a request to the Docker hub to pull this image and download it on my local laptop, right? So my request left my laptop from VS Code and went to the Docker server here and pulled the image over the internet for me. So that's what the Docker client really is. That's all it is, right? So Docker client can be present on either the Docker host or any other machine. In this case, my local machine. Docker client is the primary way that many Docker users interact with Docker. When you use commands such as Docker run, the client sends these commands to Docker-D, which is the daemon, which carries out the mount. So then send the Docker pull, it goes to the background process called Docker-D, and then it goes out to the server and then brings it back to my machine. A Docker image, an image is a read-only template with instructions for creating a Docker container. So this is the image. When I pull this image, this Nginx image from my local machine, it has all the instructions in there to create a container, right? And then when you create a container, all I have to do Docker run. So if I do a Docker -A, let's see, Docker -A ls. Where is it? Where is it? Docker PS right there. Docker PS. I don't have any containers running. -A. Okay, so there's two images, Nginx images here, right? The 20 minutes ago. Then this is a different image from 6 months ago. So I did pull the image. So an image is based on another image, right? So when you have the client, you do a Docker pull, it goes to the Docker daemon, goes to the internet, and pulls the image down. And the image is now stored on my machine. When I now do a Docker run, it takes this image, it goes into the image and see all the instructions in there to create a container, and it runs those instructions and creates a container. A container now is where we now connect to it and now see our application. The container is pretty much our application now is going to come up, and then we can connect to it using other tools like, localhost connection, and just connect to it. A container is a runnable instance of an image. A container is a runnable instance of an image. It means a container is your application. We can create, start, stop, move, or delete the container using Docker API or CLI commands. Like here, you can run a Docker stop, and then you specify the container name, which is container ID is this one right here. I just pasted the whole thing. Docker stop. I don't think it's running, but it's just gonna copy this. And that's it, Docker stop. It's not running anywhere. I just Docker stop and it runs, right? And then you can do a Docker start and you start the container, right? And start the container. And if you do a Docker ps-a, boom, you see it's running. Where is it? Status up 5 seconds ago. It's up and running now, right? So and the application is running. How do you connect to the application? They'll now give you a URL. There'll be a URL that you click the URL and you go to that URL and you're going to open up the application, right? Sometimes it's this right here, localhost, that's this. That's what you take here. You go and open up here and it will open, boom, like that. But now I'm not able to connect because I haven't configured it to connect, right? When we go deep into Docker, I will show you guys how to map an internal port to an external port to connect to the application. But that's the basic knowledge about Docker container. It's the daemon, client, images, and containers. Okay. So this is where architecture. And we're done. It was finished. This is just fundamentals. We're done. So, like I said, this is your host, my local laptop. The Docker daemon is running on my local laptop because the Docker software was installed on this laptop. So when I do a Docker pull, it goes to the Docker registry, which is the Docker server. This is the Docker server right here, the hub. This is the hub. The hub is the server. Everyone comes here. Everyone uses this. This is why I say you should create an account for yourself. It's a free account. They don't charge you. It's just a free account, right? They want me to verify my email address every time because it's been a while. So this is a Docker hub. So when you do a Docker pull, it goes to the hub. It goes to the daemon. It sends a request to the Docker server, which is the Docker registry on the hub. It pulls the images down to your Docker host. And once you have that image locally on your host right here, and then now you can do Docker run, and then you go in and run the steps and create a container, and that's it. So again, Docker pull in the next demos, hello. You run that command on your local desktop, right? My desktop. These two are connected together, right? In this case, our Docker host is our laptop, right? And our Docker client is still our laptop. They were running VS Code. So you do a Docker pull, it goes to the Docker daemon, which is on your laptop, because you install Docker on your laptop. If you install Docker on the EC2 instance, then your Docker daemon will be on EC2 instance. That makes sense. So now it goes to here, Docker daemon goes to the Docker hub registry, pulls the image to the Docker host, which is to your laptop in this case, because that's where you install Docker. And you do a Docker run, -p for port number. -p means port number. This is the internal port. This is the external port. So you're mapping an internal port to an external port. And then -d for daemon, and then the name right here, right? So you're making a call to the daemon. Everything happens to the daemon. The daemon is like the process that runs everything, right? And in Docker client, and that's it. So a Docker registry stores the Docker images, which is a Docker server on the internet. Docker Hub is a public registry that anyone can use, and Docker is configured to look for images on Docker Hub by default. We can even run our own private registry if we want. When we use the Docker pull or Docker run commands, the required image are pulled from our configure registry here. When we use the docker push command, our image is pushed to our configure registry. What does this mean? So the same way in which you can go pull an image from the hub and run that image, locally on our laptop, we can build an image ourselves. We can build an image ourselves because these images that you see here were built by other people. This is open. People build an image and push it here, right? But before you push it here, you want to push it first to your own local dashboard. So I push these images here. You see, these are my personal images that I push. This the board that has Netflix. I pushed it here myself. I push this one here myself as well. So you can go and build your own image by writing a Docker file. Like you go and write your own steps. Like I said, Docker is literally just a set of commands, like from this, do this, do this, do this, and then you say Docker build. It will take this file and build your image. Then you do Docker push, you push your image to this registry here. To this registry here. Or to your local registry here, to your own private. This is my private registry that I have. So that's pretty much it. Okay, you can see view in Docker Hub, and I'll be able to see if I can see my image in Docker Hub. Yep, that's me in Docker Hub. I pushed my image in Docker Hub over a year ago, and that's it. I don't have any notes on how to like use it and everything, but I just push the image. In my image, it's pretty simple. I'm just saying pound bean bash, environment this, run this command, copy this, do this. That's all what Docker is. All those commands that we're doing, sudo yum install this, sudo that, we'll put it in this Docker file and we'll build an image. So whenever you run Docker run, it goes and run everything for you. That's it. That's the automation piece that I was waiting to teach you guys at the end. All that step that you'll be copying, did I stop sharing my screen? That you'll be copying commands and pasting, you don't have to anymore. Am I sharing my screen?
Yes.
Yes, we can see it.
Okay. Yeah, so that's what Docker is. That's all this. It's more of a DevOps thing. I want to just give you guys a heads up. Like, you for you as many SRE guys, what you may have to do is because all you do is check things like Docker status. You may have to just run like a Docker ps-a to see that the image container, the container is running. See, it's up 6 minutes ago. Let me go and stop it before it consumes all my memory. I'm gonna do Docker stop. And then I'll run Docker ps-a. Exited 3 seconds ago. So as an SRE, since your job is to check systems to make sure they're up and running, you don't have to go and build Docker images or configure them. All you may have to do is run a Docker ps-a command to see if it's up and running. So in the interview, they ask you that if the application is running in Docker, how would you check to see if it's running? That's your answer. Docker ps-a. That's it. If it's not running, you can do Docker start and then the container ID. That's all I'm teaching you guys, the basics for your job. The configuring of Docker, building application is all DevOps. But since you're an SRE guys and your job is to make sure that systems are up and running, I'm teaching you this so you can know how to check if a Docker container is up and running. That's what we're going to do on Saturday. And that's it. We're done with Docker. That's it. It's very, very easy, right? I think it's easy. It's very, very short and easy. Any questions on Docker? So let's all do it. Let's all do it together. We're going to go create an EC2 instance. We're going to install Docker on there. And we're going to run some images. And then we're going to end class. And that's it. We're done with Docker for good. If you want, you don't need to know more. I know there's the people like, oh, Ziba, I would like to know more. No, it's for DevOps. It's not your job. Let me get my charge, I guess. Want to take a short break? I'll come back. 5 minutes, maybe. So let's go ahead and create an Ubuntu instance or Amazon Linux, the one that whatever you're comfortable with. right? Let's go ahead on the US is one. It doesn't matter. Linux, it doesn't matter. For Ubuntu, it's gonna be sudo apt install. For Linux, it's gonna be for Red Hat Linux, it's gonna be sudo yum install, right? So it doesn't matter. Anyone you want to create is fine. At this point, you know how to create an instance. So create an instance. You can call it your Docker server, your Docker desktop. Call your Docker desktop. Like I said, you can pick anyone. I'm gonna pick Ubuntu, and I'm gonna pick 22.04. Confirm changes. Create a new key pair. Call it Docker. Guys, I'm not gonna go slow with this part. You know how to create an instance by now, so I'm not gonna wait for you on this one. Keep the same security. Allow traffic from the internet, all this stuff, right? Check. And launch it. And when it's done, we're gonna install Docker. I can give you guys a document to follow. Install Docker on Ubuntu. If you did Ubuntu. Right here. Ubuntu. We're gonna install. Right here. From step 2. This is the document. If you did Ubuntu, if you did something else, let me know, right? Am I sharing my screen? Yes?
Yes.
Okay, so this is the command we're gonna run for Docker. For other operating system, if you go to the same documentation, you just choose a different one and you'll be able to install, right? If you want to install Docker on Amazon Linux, you just do install Docker on Amazon Linux. What the hell? Show me my shoes in there. So sudo DNS install Docker, that's for Amazon Linux, right? This is the document. I don't know how to show me so many shoes here, but for Amazon Linux, that's the document, that's the link. Okay, when your instance is up and running, let me know when we'll begin. We're not going to take long. We're almost done with class. It's a very easy exercise. So instances, refresh, what's going on? So it's running, so I'm going to connect to it. Connect. I'm going to terminate the old one so I don't get confused, right? Connect. So I'm on Ubuntu, so I'm going to go ahead and install Docker. First, I want to run a sudo apt-get update. This is similar to where you run sudo yum update, right? So I'm updating the server. Are we all here? Are we all on the same place? If you're using Amazon, it's run sudo yum install, sudo yum update. Are we all here, guys? Come on. Yes, no, maybe.
Yes.
Okay, it's done. So the next thing I want to run now, I don't want to do all this extra stuff. I always want Docker. So I'm going to run this command here. Let me clear my screen, and I want to run just Docker C. What's this? This means that the package is missing. Okay. Specific version. Okay, so it looks like we need to run these extra steps right here, right? So I'm going to run these extra steps here first. And then the next step is sudo install this keyrings. Okay. The next step is curl. And then add the repository to the app sources. So I'm going to run all of this. I'm just going to copy all that and run it. Okay, done. So now I'm going to go and run this installation again. Yes. And now it's installing. And that's it. Install Docker on here. She's creating a symlink. Every time you install things that you're going to use, it's going to create a symlink. Because it's a Docker daemon, right? It's a Docker daemon that's in the background of this. So now we have Docker here. To run the Docker -- version, we have Docker. That's it. 27.3.1. And that's it. You just install Docker. Everyone there? Is everyone there? You can run a Docker, sudo Docker run hello world. Unable to find the image. What was that? Locally. So it was unable to find it. So you pull the image from the internet, and that's the image that was pulled from the internet. So to run it, you can run the image And you can run docker run -this bash sudo, and it's running that image. And that's pretty much it. We can now go to the hub and pull in down this Nginx image. So docker hub, docker pull. Exit. So when you did the sudo, you switch to root. So you can go back out to Ubuntu and do this docker pull image. Then I have to do sudo. So you have to use the sudo to be able to write to the server, right? So now that you have that, you can now do a sudo docker run. You can now run the image. But you have to do a docker ps-a sudo docker ps-a. So you have that container ID right here. You have the hello world one. And then now we can run the sudo docker run, and then the image I will pull down, Nginx. It's gonna run the image, it's gonna start the processes, and then it's gonna create the container. So docker run goes ahead and creates a container. Then now we can go now and see, we'll see the container ID here in this list, and we can do a docker start, and it will start the application. And that's it. That's your job, guys. Your job is to be able to run containers. Taking a while to run. Any questions, guys? Any questions? No questions? It's hanging. I don't know why it's saying it's hanging. I'm gonna kill it and see it might have created a container already. Yes, that's it. Oh, yep, the container is right there. Nginx, that's it. That's the container ID. So sudo docker start, and you start the image. If you run this again, that's it running. That's the port 80. And then pretty much that's our Nginx application. Now we have to map this internal port and external port for us to connect to it. That's it. So when you come here and you do a Docker status, sorry, do a Docker ps-a, and you see that it's up, the application is up and running. That's what you report back to the guys. Like, guys, I've checked the application and it's up and running. Any questions, guys? That's pretty much it for today. I'll keep it very, very light. Was everyone able to install Docker?
Yes, sir.
Yes.
Yes.
Were you able to pull the image from Nginx and run the image? Were you able to follow the steps, the Docker pull image? I'm gonna run a history so you can see what I did. So the commands I did. Okay. All right, guys. Any other questions? That's it for today. You have the Docker notes. If you want to read more about Docker, practice that. Other than that, I'll say keep practicing Linux. Keep practicing Linux. That's more important. The notes I gave you guys, go ahead and complete these steps. Install these things, right? Configure these environments, and we're going to continue on Wednesday. There are some Docker interview questions here if you want to go through them, right? How do you push an image to the registry, all that stuff. But they're not very important because it's not, like I said, not your job, right? This is the Docker command cheat sheet. All the commands in here. Again, your focus will be to check if the application is up and running because you're an SRE. So you come here, you run a Docker start, the container ID, Docker stop, Docker restart, right? Docker queue. If a container is hanging, it's causing an application to hang or whatever is happening, you go and kill it, right? Or Docker network, LS, check networking issues. So pretty much how you troubleshoot issues in Linux, you may have to troubleshoot issues as well in Docker, right? So just treat Docker as if it's Linux, the same way in which you have to troubleshoot a connectivity issue or CPU issue or whatever issue that's happening. You have to understand, you have to first of all know where the application is running, right? If the application is running in Docker, then you have to use Docker commands to check the application. This is for information, right? Docker PS, right? Docker PS is for information, Docker logs, Docker inspect. So I will say go ahead and play with these commands in your environment so you're comfortable with checking for an application running in Docker. That's all. That's it. Very, very basic and very easy. So practice your Linux commands, practice your Docker commands, Docker pull, Docker PS to list all containers, Docker pull the image from the hub, right? And we'll do more practice again because like I said, most advanced companies run their applications on Docker containers. So you need to know how to be able to check if an application is running, which again, like I said, this is the command, right? Docker PS-A, that's the command to check list running and stopped containers. Okay? And I've emailed this to you, so you have it. So but again, I said practice Linux commands, practice Docker commands. That's all you need to do for right now. And prepare for interviews. Listen to the recordings, prepare for interviews. Okay?
Okay.